Hi again, Paul here, talking about the PT455. We're going to look at the calibration of the instrument, and there are two levels of calibration. The upper level, which allows you to modify the basic temperature or millivolt outputs of the instrument as far as a reading is concerned, or the low-level hardware calibration of the instrument. We can do that in the maintenance menu, and there are two options here. The first option, which can be made available to the administrative level of the operator, are the offsets. Now each input has its own calibration file, which allows you to enter offsets for any particular control loop. In this case, let's look at the furnace temperature. The offsets span the full range of the thermocouple input on this instrument. This offset can occur on the temperature reading itself. It doesn't have anything to do with whether there's a type K or type S thermocouple here. It's just altering the reading, and you can change offsets on any particular group of temperatures or all of the or the full range of temperature, depending on, say, what your survey specifications are on a furnace. Okay, the other level besides the offsets is the calibration level, which uses the same furnace temperature file in this case. And what this mode allows you to do is actually input a temperature signal into the instrument and calibrate the curve for the displayed value to, say, any range of temperatures listed here in the file. So if I'm inputting 900 degrees and I want to alter that to agree with what I know is the case in the furnace, I can input 900 degrees here, click the set button, and the instrument will automatically adjust this portion of the curve to agree with the input value that we have. On this level, you can also enter the offsets as well. So we have the ability to limit access to the calibration screen with a full calibration capability, or just allow for offsets in the earlier screen we just discussed. There's a more advanced level of calibration which actually looks at the input-output hardware of the instrument, and we'll go into that next. That's also under the maintenance screen, and if your user rights allow you, you'll have access to this internal I/O configuration button here. This is actually a separate application that runs on the instrument, so it's not recommended that you do any I/O configuration if the instrument is controlling a real process. We'll go into the I/O configuration application here, and what appears is the low-level configuration of the instrument. All 4 slots are available here, and you have the capability of designating which one of these digital inputs or outputs is configured as an input or output. Our standard configuration shows slot 1 as all outputs and slot 2 split between outputs and 4 inputs. There's no calibration here. This is just the configuration of these channels. The calibration is available on the slot 4, or where the analog board is located on the instrument. It tells you the version of the board, the revision of the code running on that particular circuit board, and the serial number of the board. If we open up the configuration, we can see what the individual channels are set up for, and as well as the inputs, we have the outputs here. And for the calibration of the inputs, we go to the this Get Status icon, open that up, and now we see the real linear signals that are coming into each one of these channels. Any channel that's configured as a thermocouple would be calibrated with a 0 to 96 millivolt signal for 0 in span. For the 2 volt sensor input channel, we would calibrate a 0 in span with a 0 and 2000 millivolt signal. Even though each one of these channels is showing the designation or thermocouple type, the calibration at this level is strictly linear and only requires a 0 to 96 millivolt signal with copper wire. Thermocouple TC extension wire is not required at this point in the calibration. Typically at this level you would clear the cal, start a 0 calibration, and then a calibration for gain, which would be the 96 millivolts. You can also calibrate the cold junction inputs for each channel, each input channel that is designated as a thermocouple, and this would require a thermocouple type input for each of those channels. This is typically not necessary on a configured and installed instrument, but it is available for low-level calibration or verification on an instrument in the field or on the bench. We can exit this particular mode by the exit icon here, and it will return to the normal process control application of the instrument. At this point, the instrument is now available for control of any of the loops operating on the furnace.